So yeah, TurkuAI meetups have been going on for multiple years. This is the second time we're keeping CIC talks, which is a format that has researchers coming from University of Turku to tell about their research together with the companies that they've done the research for. And I'm Jani Anttonen, and I come from Vätsky. And Vätsky is a local organization that is sort of an aggregator for everything IT related. We just were in Taitaja competition for Turku Vocational School, or every vocational school in Finland, for that matter, just yesterday, and we're planning to host the next meetup in a month. So that's that, and there's some more CIC talks coming over your way soon, and then we have a break during the summer, and then we're gonna have even more meetups to attend to in the fall. And just so you know, there's a very vibrant scene of meetups in Turku. So our friends in Turku SEC have great meetups. Turku Loves Frontend and Turku Aurajoki Overflow as well. So just keep in mind, if you have any meetup needs to attend to, there's also other stuff than AI. And here's the team. So there's me, there's Kai Mikael, and there's the supporting cast, Arttu Laitinen, who made these slides for me tonight. Who wanted to put himself there, and thanks to Arttu for filling in for me the last meetup we had during the spring. And tonight we have 3 talks for you. At first, there's Faruk Mehriari for Zefort, and he's going to talk about AI search for Zefort contract lifecycle management system. And then there's Iliana next up, who's going to talk about her research for Tietojenkäsittely Oy. And the last one is Poya Jafarzadeh for West Energy. So yeah, we have plenty of interesting research that we're gonna hear tonight. And let's have it for Kai Mikael, who's gonna talk about CIC, if you're wondering about what it is.
Thank you very much. I know you don't have a mic back there, so I try to keep my voice enough. Thank you for coming. My name is Kai Mikael Björk. I'm the director of CIC, which is a joint AI center in the universities in Turku. I'm here half time, and we arrange one of the activities is try to arrange the meetups also with the researcher from University of Turku, who has visited some companies and done some kind of finding there. And I'm not going to say more because it can be very different what they find in the companies, and I don't want to spoil the surprise or say something that's wrong. So I'm going to leave that to them. But thank you for this. We're going to have one more in June coming up. So if you're interested, keep track in the TurkuAI meetup. But that's it. I think we shouldn't. Oh, maybe you want to say something?
Yeah, he's gonna have his own slides.
Yeah. Okay. So before we start, some more slides, but I wanted to keep it brief just to give time for the presenters.
Yeah, let's keep it brief.
Yes.
Thank you on my behalf as well. I am Veli-Pekka from Arado. We are hosting this TurkuAI. Thank you for the possibility to do that.
Thank you.
Thank you, and welcome to our somewhat still brand new offices. We moved here last December. And this is the second meetup now that we are hosting here, so this is really fun. As a reminder, there are snacks and drinks over there, alcoholic drinks in the fridge, and non-alcoholic ones in the cooler. There are seats available still here in the middle, so in case you don't want to stand in there, you still feel free to move yourself a bit forward there. But just wanted to say a few words about Arado, the company I'm working for, and the company in which offices you are sitting right now. We sell digital services with skill and understanding. We are able to be with you every step of your way in your whenever you are building any type of software or require some type of help in the project. Our bread and butter is software development services. We sell senior developers into our clients' team to get them to strengthen and facilitate growth inside those teams. What is a senior developer for us then? For us, a senior developer is someone who can move things forward at the client, helps the team grow in terms of skill, for example, and even for example, coaching junior developers. And then, of course, has the technological skills to also do things also related to AI a lot these days. Here are some of our clients, and we have also been awarded the Best Digital Service Award by the Grant One competition just this year with our work with Taiste, working on the Hesburger's self-service kiosks. So in case maybe later today you are visiting one of the Hesburgers, the self-service kiosks, and everything you see there, well, that's done by Taiste, but what happens afterwards, we have also been, for example, with them developing the back end for those systems and also the cash registers and what the employees see. A couple of words about what we have done in terms of AI. And this is maybe something that we are really interested in developing at the moment. We see the change and we are now trying to sort of move forward into kind of seeing the whole picture, like what can be done, how it could be actually utilized so that we can provide value for our clients. Really interested to discuss about these topics with you people today, especially maybe around the subject that how to get, well, let's put it straight, how to get senior developers to get really interested about the possibilities of AI. So in case you have some cases, for example, around that, do let me know. What we have done with AI then? Well, we use GitHub Copilot. I made this really shitty AI photo, and I should probably now stop this joke before I get fired. We have actually done something actual with AI as well. We have, for example, worked together along with Linksoft, who did LLMs before it was cool. For them, we have, for example, built APIs and been a big part in their product development services. And for example, at the moment, we are developing this smart service call processing system that helps salespeople and customer service reps to bring out the right topics during the call even. In case you want to discuss this, Mika is the right person to discuss about Linksoft, and Teemu over there in the back is the right person to discuss about this one. So thank you. That was it for me. Let's now move into those really interesting sounding cases and research from companies. Thank you.
Nice to see so many faces here. Maybe I've met some of you before. So I'm from Zeffert. I'm actually one of the founders, the CTO, and I won't bore you very long. I'll let Ferry then do all the interesting talking, but I'll introduce us a little bit. So we do a contract management system, which sounds boring, and it kind of is, but we are trying to keep it interesting. So what it is at heart, it's a document management system originally. So you just put in legal documents and stuff like that, and then you can find them with search. Then we've added all sorts of things. You can also sign contracts with Zeffert, and you can produce contracts using templates and stuff like this. But yeah, we have customers. So this is the search part. We index all the documents and files that are added into the Zephyr SaaS system. You can do similarity searches and lots of filtering based on different things, just like any old-fashioned search system in a library would do, but it's better because it's much better actually than most competitor systems, which don't even look inside like Word documents or PDFs sometimes. So they might only work on the metadata. So we just find all the text at least and do some smart full text indexing on top of that. Security is a sort of big thing that affects a lot of what we do. This is one reason why back when we started adding some AI functionalities into Zephyr, we developed our own models instead of just like shooting all that content into some Amazon API, because we have customers who don't want to send the data to other companies, or especially companies maybe in the United States. So there are some restrictions. The search looks like this. There's a search box, and then you type stuff in there, and then you find contracts. There's metadata extraction then. So when you add a document into Zephyr, assuming it's a legal document, some sort of contract, what we do is run some of our text extraction first on the document. It could be a scanned PDF, or it could be a Word document, or whatever. We get all the text out of it, and then we run some models on top of that to extract things out of it. So we extract basic things like a title, contracting parties, and some key dates and stuff like this. And this is all done with our own sort of proprietary models that we've developed over the years with great effort, let me say. So those little red arrows show the parts where we have some metadata. Then you can give feedback like, okay, this notice period wasn't correct, or you missing, and then you can paint something in the document that teach the system that this is where it's supposed to be, and it eventually will learn. More recently, we've added some large language model stuff here. So as you might expect, something people might want to do is ask questions about documents, like what's the governing law of this contract, and then it will read through all the text and find the answer for you. It works in a very simplistic way. It just feeds all the text into model, maybe in chunks if the context window isn't large enough, and then pieces together the results. And this is what it looks like, kind of similar to ChatGPT or something, but it always has that document text or contract text as sort of background. And it then highlights also the part in the document where the answer was found. So that's something that ChatGPT or things usually don't do. But then the next thing that we're doing is adding some RAG capabilities so that you can ask questions about your whole contract database instead of just one document or one small set of documents. So you might have, some of our customers have hundreds of thousands of documents, or closing to 1 million now. So can't really run all that text through a large language model whenever somebody wants to ask something. So it needs to be a bit more smart. So that's why we have Ferry doing things for us. And with that, unless you have questions about what we do, I'll let Ferry take over and explain what he's been doing. All right, thanks.
Thanks. Hello, everybody. My name is Farrokh Merhyari. I'm a postdoctoral researcher working in Turku NLP University of Turku, and now I'm also a senior AI consultant working for Zephyr. So I would like to seize the opportunity first, say a big thank to Kai Mikael and Jari for making this happen, then to Arado for hosting the event, then to Ville for trusting in me, and then to my supervisors, Philip Ginter and Sampo Tuisalo, which has basically helped me all these years to get prepared for this kind of projects. But let me get started. So as Ville said, there are very good searching capabilities and chatting capabilities already implemented in the Zephyr ecosystem. now I want to compare what we have in the chat side and what we have in the search side. So the search side, if you look at the left, you see that it supports full text indexing, also searches based on vector representation, so you can do fuzzy search, and it combines both of them. So you can have, and it also supports logical operators. So you can have something like minus Microsoft and liability, means all the documents that doesn't have the word Microsoft in them, and then have something like liability. And then it has text highlighting, which basically matches with any liabilities in those contracts. And then with this, you can search your entire contract base or contract database. And as Will mentioned, there can be millions of contracts. One thing I want to go into a little bit more detail is that one contract can have multiple attachments as well. So there can be NDAs, there can be anything like with a contract. So once you are searching one contract, you are not just searching one contract. So the number of documents in the system is basically huge. What are the limitations of this search, even though it is pretty capable and like serves like many clients every day, is that it only highlights the relevant parts of the text that it finds without providing some answers. And then it is not powerful enough to answer very complicated questions. For example, find all contracts that end this month and the total amount is higher than a value of X, like in euros. Or have a liability similar to a statement X. Or what is the total liability in my contract base? So now you have to search and then like find what is the total amount. On the other side, we have the Zephyr AI chat. Basically, you can chat naturally with like one contract and its attachment, also like multiple contracts if you wanted to. It is backed by OpenAI models. Also, we have in-house LLMs running on secure servers for that. The UI is very similar, as you noticed, to OpenAI's Playground. And it can and does answer users' complicated question. And for extracting the metadata, it extracts answers as metadata, as you noticed. The limitation is that it is slow and really expensive to run, especially for those clients who have hundreds of thousands of like documents. And the average length of the contracts, or 85% of the contracts, are less than, I would say, 8K tokens, of course, depending on the model. I'm just giving a rough estimate. And 99% of one document is less than 30K. But still, it is really heavy if you want to search like multiple contracts. Even if you want to search one contract, what's the problem? The problem is that if you want to do like a simple question, so what is the total value of this contract, or what is the ending date, you have to crunch all the text. It means that all the text unnecessarily needs to be processed, given to LLM, which is not a good idea, and it takes some time. So if we look on the left side, with the search, we can search the entire contract base. It is pretty fast, relatively cheap to run, but it's not powerful enough to answer users' complicated questions, and only highlights relevant parts without giving a proper answer. On the right, we have a pretty nice AI chat, which can answer very complicated questions, but it is slow and expensive to run. And metadata extraction is not suitable for asking ad hoc questions, like just chatting like with the system. And the question is now, can we build a system that is kind of like inherits the best of both worlds? And that's where the idea for a component, or a new component in Zephyr ecosystem, actually was born. We call it AI search. Basically, the idea here is to search or chat with your entire contract database very efficiently, as fast as possible. And the answer to this question is that yes, and the solution I propose is kind of basically based on a retrieval augmented generation, but a heavily modified one, as you will see. So what is a RAG? So any RAG system has two phases: indexing phase and application phase. In the indexing phase, you basically put some contracts into a vector database, and in the application phase, you basically ask questions and you receive your answers. So in the indexing phase, if you look, so contracts and the metadata comes from some servers, and then there is a backend script And then this is the plugin that I have written and I'm working on it. So it receives a contract text, it chunks it to some chunks. We have chosen to use overlapping chunks here. And then once the text is chunked into smaller pieces, now we get the embeddings for that chunks. And we support three things. We can get OpenAI embeddings, but some clients don't want us to do that. And you have to pay for that, which is not a good idea. Then you can run get the embeddings on top of a VLLM. That's also possible. We have secure servers running different models and VLLMs. The VLLM turned out to be not providing every capability we want. Therefore, I wrote a HTTP server around a sentence transformer package. So now you can load every model and then you can say tokenize, detokenize, get the embeddings, document embeddings, query embeddings, and so on and so forth. So once this is done, then we have something called like upsert. And upsert is different from update in terms of vector database. It is not update. All the time it gets first deleted and then inserted. Anyway, so the vector with some attributes are inserted into a vector database, and those attributes are really important. For example, here I have these are just examples: account ID, contract ID, document ID, and language of for example, the text. Why it is important? The account ID allows that you don't have any leakage between different accounts. So if I'm like one client of Zephyr in a bank, and then there is another like a client, you don't want to show contracts of somebody to someone else, so this is to ensure security, but it is also to ensure speed. It can be used in clustering, partitioning, and indexing, which we are using all of them. So what happens once you put all of the vectors with this attributes there, then you can have a UI. So with the UI, you can have query and the attributes. Then we have written lots of logic and prompts here, which comes to this plugin. And then you get the question embedding. And then the job of the vector DB is that basically compare one vector with 600 million or more vectors in a fast fashion to fetch top promising answers. And this is the first place you see that how AI search is very different from a conventional RAG or vanilla RAG. In normal vanilla RAG, if you have developed, you usually can get away with top 3, top 6. But if our client have 1 million contracts, and then for each contract we have 100 vectors, you want to search all of them. So that's your kind of top K. So because you want to search entire contract base to see what is going on and answer that questions. Anyway, so what are the benefits we are gaining here? There are a few. So complex queries across the entire contract database is now made possible in a very efficient fashion. If you remember, the normal search does not support complex queries. AI chat is slow and expensive on multiple contracts. AI metadata extraction is also expensive and cumbersome. But the AI search will provide advanced search across the entire database in a relatively less expensive and faster fashion. Second is that now you can chat with the entire contract database. It was not possible with the current AI chat, but it's going to be possible with the AI search. Will be relatively cheaper and faster to run compared to the AI chat. And then the things is that we can improve the retrieval recall with better vectors, with overlapping chunks. Like a sliding window. So if you have one paragraph, we make multiple vectors out of that one paragraph in a sliding window fashion. A sliding window fashion. And if any of those vectors is fetched, then we can use the whole paragraph text. So this can improve the recall. And then there's gonna be no missing information between different paragraphs because that's a sliding window. Another benefit is that like a normal search, normal keyword search, if you're searching for something like party and the parties to the contract had accepted the following terms, so if this is something like this is returned, then this word like a party can appear in different languages. And we have contracts in many languages. At least I have seen all European languages, many Asian languages. So these parties can be osapuoli in Finnish, part in Swedish, and so on and so forth. But because you are using like multilingual text embeddings, that take care of this part of the search. And then what it enables us to do is that a statement search based on the vectors. So for example, you can have a question to the RAG system, give me all contracts with similar termination and notice period. And notice period that it is mentioned, for example, in this contract is that either party may terminate this agreement within 30 days, written notice. But as you see, here are just 5 examples. The same information can be written in English, but also in other languages. So now you can have a statement and then search your entire database based on these statements, which is very advanced. Then we have thought about improving like even further with system-wide and user-defined like vocabularies, custom-defined. So remember, Zephyr has clients from many different domains. Banking, economy, IT, the power grid, and so on and so forth, and they can have different jargons and abbreviations in their contracts. So here is like an example. ADR, alternative dispute resolution, is VRR, some word in Finnish which I cannot read, but it is like ADR in Swedish. But sometimes they can be like very different. If you look at this row 6, LOI is the English one. TKV is the Finnish one, and then SOI is the Swedish one. So you cannot accept even the best multilingual text embedding model to know all of these jargons for all the languages in the world. So therefore, for example, each client can define its own terms and abbreviations in different language, give to the system, and then later we can, once we are searching for something like ICC, we can also search for KTK. And so on and so forth. Then we had this problem how to scope this gizmo into a POC, MVP, and subsequent phases. Thanks to one of the members in our group, we conducted hours of interviews with different clients, asked them what type of questions would you like such a system to be able to answer. And then we recorded all of them. And then basically we noticed that, this is really like vast. Let's categorize it into different groups. Then I came up with 4 different questions or criteria to divide these questions into like different groups. So C1 is does the question require full contract text? No or yes. No is that, okay, one query per contract would be enough. For example, this is not how we are going to do it, but anyway, what one query for the contract is enough. One vector search is enough. And the question is that, okay, give me all contracts that, by the way, these are real questions written by the clients I'm now reading here. Include information about service X or product Y, or where the location is the city in Finland or other cities. And on Z date. So give me all contracts that ends end of this month. So basically they want to renew, call their clients. Or have a clause about X, have a termination clause similar to X, like with wording similar to a given clause. And if the answer is yes, you need full text or you need multiple queries for that thing. This is usually the case where you are asking about different attributes that do not usually co-locate together in the same chunk. For example, the question could be end date is bigger than this date and the location is XYZ. So you cannot expect to do one query to RAG to fetch a chunk that contains information both about the ending date and the location. So you may need more than one query to fetch something like that. Or alternatively, if you are using an LLM, then you need the full text. And then, but it can be like more complicated than that. The field that how much do we earn on this contract. If earn is simply just the total amount, then we are good. But if earn is how much we gain, but how much we have to invest or how much we have to spend, then earning needs some calculation. So this is not something that you can get with one query from the text. It needs a full text or multiple queries. So this was the first criteria. The second one is that does the question require an aggregation, computation, or iteration, counting basically over all or some contracts? If the answer is no or the answer is yes, and the answer is yes, it's gonna be really problematic. So how much do we earn this year? And the guy has 1 million contract. So you have to go through all of them, and then you have to extract one value. And what does earn mean in this contract? And then add them up. And if you miss one of them, then basically the answer is incorrect. Or what is my total liability? That's another example. How many contracts do we have where credit support plays a role? So this is like a SQL select const star. And that's problematic. Again, if you miss one of them, if you have less than 100% recall, basically perfect recall, the final answer would be incorrect. But they want to ask this question from an AI, and I still don't know how would be a proper way to do that. C1 is that does the question require multiple logical and or reasoning step? No, which is self-explanatory and obvious. Yes, is that multiple logical and or reasoning steps are needed. Here are examples. What is our fee on largest 100 contracts we are having? So first, find largest contracts, then find fee per contract. Or show me 100 biggest contracts in terms of volume and duration, and show me the handling fee in each of them. Another one, find all information about our new product we are offering in England. What is new in England? And then let's find it. And this have a solution. So this needs reasoning model and agentic RAG, like architecture, like multi-agentic RAG that can be implemented. The last one is that sometimes they want to ask the question which is not inside the text. So it needs some kind of like integration with other databases or things in Zephyr. And that is one funny example. What is our fee on largest 100 contracts where the contract language is Russian? So you need to also like check the language of the contract. Anyway, for the POC, we said that okay, let's go easiest. So everything should be in the easiest way, and then we selected 50K contracts from 10 carefully selected and hand-picked clients, which cover like many different languages. That's our aim. We don't want to have a system that works perfect on English or just Finnish or Finnish Swedish. So we want to see like have an overall good balance on all of these languages. But for the MVP, we are aiming to put all the contracts. So we have a few million documents, and then which is gonna be few 100 million vectors, based on how much overlap we want to do and what window size we want to select. My estimation is that at least 400 million, maybe to 600 million is the scale we are talking about. And then, okay, now let's talk about scalability and the architecture. So what to do, because this thing is kind of like huge. So first, the VLLM and then this sentence transformer HTTP server, which I've written, both run on GPU and CPU, and we can have multiple instances of them, do load balancing, so we are fine in that. Then for the vector DB, after careful consideration, I have chosen Milvus for multiple reasons. So it supports clustering very well, so you can have different instances running on different machines. But it also supports automatic partitioning with key partitioning. What does that mean? It means that you can have up to 4,906 buckets, and then the account ID, for example, is you can get the modulo and then a hashing, and then contracts of these clients end up in this bucket and contracts of that. So we are now trying to making the search space as small as possible. It has also something nice called multi-tenancy. You can force all the contracts or documents of a client end in a partition and nothing else. So this is a very good thing to ensure security, like yet another step for ensuring this the security. Then it have multiple indexing and searching schemas for the embedding themselves. So cosine similarity is nice, inner product is nice, but how you want to index 600 million things. So there is always a perfect recall versus a speed versus available memory and GPU like is in place. So it supports different indexing as well as searching schemes based on what you want to use. As I mentioned, multiple search strategies, and then it can also, we can put indexes on attribute fields. So this is something nice. So if a client just wants to focus on like particular documents, contracts, or Russian documents, so on and so forth, having an index on them makes them a bit easier. Finally, it supports hybrid indexing and hybrid search. It's not easy to do that. So something, if you're using something like a VV8, it is just in place. So if you are using VV8, all the time you are using hybrid search. But in Milbus, you have to do a few more steps, actually 7 steps to make it possible. So on one hand, you have dense vectors obtained from a sentence transformer, embedding LLM, whatever. But then you can have a sparse vector obtained by algorithms like BM25 and the rest. So once you search, you get your top K based on dense search. You get another top K based on sparse search. Then you normalize the scores, and then you re-rank. So it supports hybrid search. And then in the re-ranking, you can have a knob basically telling how much weight do you want to give to your dense vectors, how much you want to give it to your sparse vectors, like 0.9, 0.1, 0.8, 0.2, so on and so forth. Now let's say some conclusions. So while existing Zephyr search and AI capabilities are like performing very well, based on the customer and client feedback, which we periodically gather all the time, this AI search will make them even better and is able to provide answers to more like very complex questions. This will significantly improve user experience by making the system much faster and cutting actual cost in companies, basically saving human effort. So if you are working in the HR department or I don't know, legal department of a big company, and then you want to know which contracts like end this month, which are this and that, then you have to spend a lot of time even in normal contract management system to find all of them. But here you just write your thing, press a button, and then you have a list of them, you know who to call. So it actually saving like a lot of time. And what I can say is that a vanilla RAG solution would not be perfect solution for this AI search. Therefore, we had to implement, basically I had to implement our own chunking logics and the prompts that I'm going to write, different setups, what indexing we want. So it is kind of like a heavily modified RAG, if you will. And final point is that the range of technologies that we have selected for this, at least on paper, let's see what will happen if we put like 600 million records in it, but promise a good scalability for hundreds of customers and millions of contracts and few hundred millions of vectors. So yeah, thank you for listening, and then I'm open to questions.
Please go ahead with questions. Just don't raise your hand. Just ask your question.
I was wondering how, like, really interesting. How much will this cost for the customers to use this one? This is probably not like the normal standard feature that you provide? Like, how do you kind of get paid for it?
That's a political question. I prefer Ville to answer. None of my business, so Ville.
I will refer this question to the salespeople. No, I mean, it's probably going to be a paid extra module. Like currently we have what we call advanced AI package that includes a lot of the AI and LLM-based features, something similar to that. But it's a bit open. We haven't decided yet, but probably we can get some money out.
Yeah. I mean,
But yeah, and of course, there's the question of covering costs. So obviously it needs to cover costs, but it's like we look at the total amount that we get from a customer. It doesn't have to be just like not every feature needs to be profitable on its own. So the whole package just needs to be. So really, it's a political question.
Okay, about the hardware, because you're saying you need a lot of RAM, of course, and you need GPU and you need CPU both, and you need a lot of storage space if you have like hundreds of millions of documents.
Yes.
Where is it? Is it going to be on site in the company's own, or is it going to be cloud service or whatever? Because that's
As Ville mentioned, we don't use any cloud services
so it's going to be
because
inside the company, so it requires a lot of
Yeah,
hardware.
we do use a cloud service provider, so we don't own our own hardware. We have some, but most of the services we buy from Hetzner actually. So Hetzner GmbH, a German company, have a data center in Tuusula, Helsinki, and one in or a couple, I think, in Germany, and one in Paris, where they have most of the GPUs. So
Yeah, so yes, so it's cloud service based, yes.
But
The
inside
cost
the-
can be estimated, but still not sure yet how are the things going to be quite a lot for each.
the running cost of it isn't really a huge factor. Will increase a little bit, but not like multiply it or anything like that. And the big cost is still engineering.
Okay.
And the good thing I can say in terms of technical things is that something like Milvus is scalable. So with the clustering, if you later need more, you just add one more node to your cluster, add one more node to your cluster. So you don't need to invest a lot in the beginning. We should see how many concurrent clients are going to use this thing. What's the load? And then if the systems like become slow, then we can expand on it. Basically.
But yeah, you can kind of do some back of the envelope math of how much it will cost if you think that one dedicated hardware box from Hetzner that has 128 gigs of ECC RAM is about 80 euros per month. And we'll need, if we had all of our data, all of our customers' data, we need some number of terabytes of RAM. So it's not like a huge cost.
Another thing which is in our roadmap is profiling the system in terms of speed, not accuracy. So what would happen if I want to like traverse 100,000 contracts and their documents, and then once somebody writes a question and presses the button, if there is no filter going on, we can say that, hey, this takes 28 minutes. Do you seriously want to wait, or do you want an email? So something like that should be implemented and asked from the client. Yes.
Yeah, have you evaluated the RAG system? Like, how well does it compare to like full, like if you give the full contract to LLM, or like the example questions like find me the biggest contract, like does it actually find the biggest contract, or is it like it will just give you some answer, or
Very good question.
are the like answers actually correct, or is it are they just answers?
No.
Yeah.
It boils down to, you see this red, like yellow part.
The magic yellow box.
The magic yellow box. So everything happens here, and then everything should be improved here. So the way is that you say, for example, there are two ways. Let's start with the dumb way because it is easier to understand. The dumb way would be to one vector DB query per contract. So get me what I'm earning or what is the total. Then I receive a chunk. Then I have this chunk, right? Then I gather a list. Then I can pack them, ask LLM, is this really what is asked or is this nonsense, right? Then you get some yes, some no, some yes, some no. And then if you want to go even a little bit better, you can also give to LLM the score of the retrieval. So it can judge if the score is like below this thing, so maybe it is not a good thing. So, and once it is done, then you get some answers and then you get a max.
Okay.
So yeah, that's how you can do it. The other way would be these vector DBs have some limitations. For example, in the Milbus there is 24,000 something number. I don't remember exactly, but that's the maximum of the top K that you can ask. So if there are more than that many documents, then you need some way to traverse a batch of documents to ask 20K at a time, process them. Then the other thing which is seriously important in the RAG is question reformatting. So the first question is that who is CTO of Zephyr? The answer is Ville. The second answer is that when was he born? If you start searching when was he born in your database, you don't find it. You have to convert this original question, which we call query reformulation, into something, as we call it, a standalone question. When was Jussi, the CTO, Ville, the CTO of Zephyr, born? Now, if you start to search this thing, then basically now you can find the answer. So the client may write whatever in the UI. It's our job to decompose this question into different questions, decide if the system as it implemented right now is able to answer that question or not. Does it require multiple steps queries or not, and so on and so forth. But all of that happens in this yellow box.
Okay, all right. But is there any way to evaluate, like,
Yeah,
how
sure.
confident we are in this answer to the client, or is it like?
One of the things which has been ongoing before I joined Zephyr and now we are like extending is basically doing some benchmarks, or own benchmarks. So you know the question, you know the answer, right? Once you put everything there, you write a question, you expect to see those answers. So this is like or gold data set, whatever you want to call it. Yeah. But yeah, those benchmarks are going to be like used because there's going to be a lot of performance tuning. There are a lot of parameters to tweak. Should I use this LLM or that LLM? What should be top K? What should be the indexing strategy? What should be the search strategy? If the params the parameters are good or not, and so many other things. And nobody can just fine tune them by hand. So this should like be automatized, which is now ongoing.
Yeah.
But this is a usual stuff. I'm not doing something crazy here. So this is a usual stuff in any RAG. And I believe we have run over time.
Yeah, I mean, we can continue discussing your presentation, your research.
Okay. Yeah, once
afterwards.
again,
Yeah.
thanks everybody then for listening.
So yeah, let's keep a small break, 5 to 10 minutes, and
And then,
continue with Ileana's
So I
presentation.
I can start arranging things. Good evening, everyone. My name is Ileana Montoya Perez. I'm a senior researcher at Turku University. I've been working in Turku University more than 8 years, so I see familiar faces here, which is really nice. My research has been always on machine learning and more like model evaluation, developing methods for evaluating AI, for example, and also doing data analysis and applying AI to medical data. However, thanks Kai, because you allow me to shift a little bit, and go more in contact with industry. And I had this opportunity to be discussing with Tierra, on using AI to enhance their services. And this is what we're going to be discussing in this presentation. So I made like a little overview of the presentation so you know how is it going to go. First, there's going to be an introduction of the company, so the overview of the whole company and its mission. Later, we're going to talk also about the ICT services that the Tierra offers and the solutions provided by Tierra. Then, of course, if they provide services, they also need to give support to those services. So we're going to focus then in the service desk, which we want to enhance with AI and improve those services. So it's more about, this presentation is not going to be too technical. It's more about what are the problems that are in the company that for some reason, like AI can really help and facilitate things. And last, we're going to do the conclusions and the discussion, and then we can ask questions and we can talk about what is this. Okay. For the introduction of the company, Jari Komulainen will be doing the introduction, as he's worked there and he knows more about it.
Okay, so I am Jari Komulainen. I'm working in Tierra. Formerly, I was Kuntien Tierra, as some of you know it. Tierra was founded in 2010, and it is so-called in-house company, has about 400 municipal owners with and well-being services. And like in there, you can see that Tierra has about 22, I think at the moment it's almost 30 offices around Finland, because we just got some new contracts and clients going on. And our goal is quite simple. We aim to create direct impact benefits by helping municipal operators and well-being services to free up time for operational development. Most of clients are cities, counties, and the people in there have no knowledge about computers and how to use them. So that's what we are in for. We provide them the systems, we provide them the services they need, and we are offering that because it's a full ICT service. Like all companies always show that, okay, we are so good, we are so nice, but we also have to show it. That's always. Then this is short, like about the business operation we have. We have a lot of stuff, and for this whole meeting idea, we just forget almost everything from this page. But we have a lot of stuff that we are doing, but we just use on one, focusing on the ICT service, and the service desk actually is what we're going to focus on. But then the point is, we are doing this. We know all our customers. That's how we are doing it. That's how we work with. If you don't know and if you don't give a good service, they are going away. You can't keep them. That is quite simple. And we have basically everything. We have had some customers, some cities or counties that had nothing. They just had paper before, paper and books. Now they have full digital services, everything online, everything working. But that's what we are trying to do. And let's give it back to Ileana.
Okay. Thank you, Jari. Okay. Now, just to summarize a bit, what does a Tierra is providing? So now we know that Tierra customers are the municipalities in Finland, and they are kind of the owner customers, right? So they go to Tierra for Tierra to provide all the digital operation environment. So all the digitalization is all the services, software, hardware, all the digital is. If the municipality wants to develop some service, they will also provide all the infrastructure, all the technology that they need to provide that service. And also in the digitalization advancement, that means that if they have an old system and they want to move to a new system, then they will provide the whole structure. Tierra will provide them. So just to look through it, the ICT services they provide is like information management systems, an expert work, project work, application support, information security development, and all the critical ICT infrastructure. Of course, as you know, if they're providing these services, if there comes some error or something is not working properly, they also need to provide some service desk, and so that the customers can call Tierra and find a solution, report the error, and find a solution. Tierra is providing different channels for the customers to contact. They have emails. You can just write an email and say, okay, this is my issue, and that will generate some sort of a flag or ticket. Then the web portal, that is more like a structure, a form that the client can just fill in, and that will go to Tierra. And of course, the phone call, which is the most common. Because just think about it, like if your system is not working, your computer is not working, how you contact them to report the error. So usually a phone call is how things are done. So now each customer has this interaction with Tierra through the support ticket system. And this ticket is the one that will keep track from the beginning to the end of how the issue has been handled and until it's solved. Okay, until it's solved. So I think some of you already have used help desk services, right? Like you call the service, and you see sometimes it's so annoying, or it could go smoothly, or it can be very bumpy. So this is where we have identified things. So in those channels that they provide, there might be some challenges. And those challenges that are there can be solved or can be enhanced or facilitated by AI. They can bring some solution to it. For example, if the client is just writing an email, a unstructured email that Tierra received, the email, with that information that is in the email, a ticket has to be created so that an agent has to read the email and create manually a ticket. So what are the challenges? Well, the emails, they're of awful lack of proper formatting, and details can be missing, so missing information. And also the ticket has to be created manually. So how can this be improved? The AI is already there. We know that you can apply text mining to an email and extract those keywords that are needed for the creation of the ticket. Also, if there's some missing information in the email, the AI can also, from some database knowledge or some historical information, it can just retrieve those missing values from it. And also it can keep track of the valid information, like if all the information that have been gathered is correct, so that the ticket can be created. So this is one of the most straightforward where AI is applicable. Right now they're not using it, so this is a way to to find that AI can be used. Then it comes the web portal. This is more structured, so you have a form, so people are typing the information for the issue, but still, even if you're typing, you're gonna make mistakes and incorrect. For example, you may mistype the phone number. So and at the end also, if everything is correct, still it needs to be validated by an agent. They have to read and then create the ticket. So here's how AI can improve the process. Well, first of all, it can prompt the user for correction in real time and validate the inputs. For example, if there's a mistype on the phone number that is required, then immediately the AI can help or fill it in for the user instantly. It can detect and correct inaccurate information, like using those past tickets and user inputs. And it also, it can monitor the ticket status until the required, all the valid information is there so that the ticket can be created. So those are two ways straightforward where AI can be used, and it will really facilitate things, right? Then we come to a little bit more complicated, and it's the phone call. And this is the most common one. People usually call to the service desk, and this is kind of the general, very up-to-tap workflow. Things gets a little bit more complicated. For the first thing is that an agent from Tierra, he answers the call from a user. And the agent has to gather the information to generate the ticket. So what is the first thing? Well, identify the caller and the device. and identify the nature of the issue. And then when that information is gathered and is together, well, they could just build a ticket. Well, then comes the next part. The ticket is generated. So now the agent has to find related tickets. Does that customer or that user has already some tickets in the system related to that issue that he's reporting? If it's yes, well, the new ticket has to be attached and they will act accordingly. If it's no, then the agent has to say, okay, does the solution exist for that problem? If it exists, then the agent tries to fix it, okay, by telling the user how to fix the problem that it is. If not, with a solution that has been already reported. If not, does the agent can fix it? Does he know how to fix that? If yes, then he will fix it. If the issue is solved, then the ticket is closed. But if it's not solved, it has to escalate to another expert, or it goes deep. So so this part, we're going to be just focusing for the AI in the process of creating the ticket. But as you can see, there are many things where AI can be used. It's not just limited for the ticket creation. But because of the limited of time, that we're not doing really research on this, it's just like kind of getting to know the company and where are the needs. We didn't go into all the whole process and the whole workshop flowchart. So, okay, these are the challenges what you're doing when you call to an agent. First of all, miscommunication and misunderstanding. So remember that when you call to a help desk or a service desk, there are emotions. People are frustrated. So the agent and the person are like kind of discussing, like, okay, trying to find out and agree on that. So the agent has to be patient and try to gather all the information that is needed for creating the ticket. Like the name, the location, very basic, but still sometimes it's very hard to get it from the users. So there's gonna be incomplete and unclear problem description. Sometimes the users, they don't know how to describe what is the problem with the system they have. So there's gonna be poor call quality and some stable conditions. Yeah, sometimes when you call, they can not hear themselves like properly, and at the end, everything is done manually. So the ticket has to be created manually. So how can AI improve the process? Well, I think some already kind of most of you know the answer. Of course, when it comes to miscommunication and misinterpretation, AI-powered speech-to-text transcript, like convert the call text in real time and reduce that will reduce the risk of missing details. That could be an option. Another thing, it will be entity recognition algorithms. So automatically identify and extract the personal, from the conversation that is being transcribed, extract all the important details and the keywords, like names, device, type, location. So that as you see, it can really help. Then, if there's an incomplete or unclear problem description, well, during the call, the AI can prompt the agent and just make some clarification questions like, okay, these are what you need to be asking based on the context of the call. It can also categorize the issue or auto-summarize what is going on in the call, fill the gaps based on the context, so that can help and facilitate things when it comes to unclear description. Then we have poor call quality or unstable connection. So they are like AI-based audio enhancement to reduce the noise, background noise, or the audio, enhance the audio, make it more clear. Also, they can use AI chatbots. For example, sometimes when you're calling and the call just stops or falls, then you said, okay, what do I do next? So the AI can keep track of what has been discussed already and send SMS or send an email to the client and just summarize what already has gone and also give some instruction to the user on what to do. Like you have to wait for the agent that is going to call you back, or it can provide, and that will calm down like the situation. And then when it comes to manual data entry, well, as you know, this is time consuming and error prone. So they automate ticket generation based on what is being discussed in the call. Based on the conversation, the ticket can be automated, created. And also this is a little bit voice assisting integration in the case that you want just to dictate, or he will capture based on the voice, and so that it doesn't have to be manually typing the information. That could be another possibility there. But as you see, there are like always solutions for all this inconvenience that can help enhance the experience of the system. Okay, so that was it. So now in conclusion is that it brings using AI in this ICT support ticket creation definitely will bring benefits. For example, it will enhance this user and agent experience. It could improve the accuracy and it will improve the consistency, like how valid is the ticket data, and reduce the time in creation, like the creation time of the ticket. As I said, this is just like we just scratched the surface. There are a lot of things that can be done with AI in these kind of companies. And for example, for future application of AI, handling how the ticket is handled and how they found a resolution. AI can also check history, past solutions, and provide the possible solution for the same kind of problems. Everything that is coming in is information that can be learned by the AI. So every time that every ticket that comes in and is solved and issued, that is information for training the AI. And of course, data analytics to optimize the services, to forecast, to predict what's going to go, if something's going to go wrong, or what are the common things that are going wrong in some environment. So as you see, this is quite straightforward. It's quite simple, but I think there's a lot of potential for this kind of company to use AI. Thank you.
Thank you very much.
Yeah.
Questions, but I will start first with my comment. You're so right. I mean, when I try to fix something on the phone, just sometimes if I need to say my email, when I say my first letter from my first name and then my last name, but not with the 2 dots on the O. And still, half of the time it's wrong. An automated ticket email back to me or some messages what is kind of received during the email. And the best thing this was in the US. I tried to get the support and they say, okay, we reset your password. Your password is going to be small caps ABC123. And I said, isn't that a little bit too simple? No, you go and change it, but we cannot have difficult words. So you understand ABC123 is something that you can do over the phone. So I tried ABC123. No. Capital letters, no. And then I called back, it doesn't work. No, A, B, Z.
Oh, it's so, like that, yes.
So many things can go wrong when you talk. So I think automated ticket is a good example. But hey, go ahead, sorry.
Yeah.
Big question, comments.
But it also usually feels like you're getting better service if you call instead of communicating via email or text.
Yeah,
that's true. Also, it depends on how you behave when you call. There are people who are like, I want it fixed now. Okay, what do you want fixed? My computer. Yes, okay. What is your computer? It's an HP. Okay, where are you working? At home. You're not gonna get any service on that.
Yeah.
But still, they expect that you give it.
What about AI in that
Well, AI can just detect who's calling, what it is, the location, and provide us and said, okay, calm down. I know who you are. Like
Yes.
the agent can interact in better ways because the AI can. And these techniques that we're talking of AI, they're already developed. So it's more about developing the software and taking advantage of it and just implemented it. Yeah, of course, it looks simplified. I know it requires a lot of stuff and a lot of work, but the techniques are there. So it's just to connect the dots, I always said.
So is there some sort of proof of concept that you've done for Tiera?
Well,
Or
no,
do you
we
have-
haven't worked, but Tierra is looking for companies that are building these connections. They don't want to do an in-house development. They want a company that can give them the support that they need for AI applied to the help desk, service desk.
To Tiera, the biggest thing would be actually to any company to start building a core system that can take inputs from language models, from text inputs, from whatever, and also take input from all these different help desk ticketing systems. There are those Jira, Service Desk, Effect, there's a lot of those. And if somebody can make like that kind of program, it can be used with almost any service desk anywhere.
Anyway, yeah. Services is not only for theater, like all the companies have. So this is like a big opportunity for people that are interested on, developing something big, a help desk, or that uses AI.
Yeah, Tiera is
as
at
an
the
help
moment
desk.
is looking with several providers. One is providing only for emails to be given as a ticket. One is only trying to get something else, and one is something else. I think there is 4 or 5 different projects going on, but they are all just one simple thing, and it's not working.
And yeah, they're also developing these chatbots, which is very simple, right? But still, the agent has to do so much. Still, the AI part is lacking, and that is kind of for people that are working with AI or trying to get into it. It's like quite straightforward. So I think there's a lot of potential in this kind of business. So as you noticed, like my research wasn't that so technical, but I really learned a lot and found that there's the need, and here it is. So thank you so much.
Yeah, that was only the service desk in Tiera.
Yes.
There is a lot of other stuff. We have this smart city. We are providing a lot of stuff for the, for example, the city planners. They make all the city maps in who goes where, who does what, wherever. We have all those connections. AI can be used in multiple places, not just in service desk.
Yeah. So
So
I think
Okay.
no more questions.
perfect.
And as usual, the conversation can continue during the break.
Yeah.
Let's have a short break again, and then for the final talk.
So yeah, please give it up for Poja ja Farsade for the last presentation. And we still haven't announced, but we do have a plan to go network after this. So please join us at John Scott's.
John Scott's, just across the street.
Just across the street. So yeah, let's not stay at the office for too long afterwards. Let's move to the pub next door. But yeah, thanks, Poja.
Yeah. Hello, as a last speaker, I go shortly. I know you are a little bit tired,
We're
but
not in a hurry.
yeah, my name is Poja Jafarzadeh. I'm researcher at Data Analytics Lab in Turku University, and I'm member of DPT steering committee in Turku University. My talk is about intelligence based recognition and classification by machine learning and machine vision methods. So a key component of sustainable development and circular economy nowadays it's efficient recognition that improve waste handling and reduce environment impact. Traditional methods is not enough anymore. They have limitations. They are not sufficient for accurate and identifying and directing various materials. in processes, in industrial processes, with benefits of machine learning, sensor fusion, machine vision, and combining these together, we bring significant improvements in waste detecting, identifying, and also analyzing. So this project is handled by Turku University and West Energy. Now, West Energy is a leader in producing heat and energy by waste. The company owns a modern waste to energy plant where combustible waste is refined into electricity, heat, and recovered materials. The company owns a modern waste, and they are situated in Vasa, near Vasa. One of the major challenges is a mix of non-combustible materials like metals, glass, construction waste, hazards with combustible waste, and impacting energy and efficiency and increasing process costs. Also, contamination of waste streams hinders effective recycling and entry production, requiring advanced sorting technology to optimize. We need advanced technologies to optimize the recycling processes. So in this project, we first mapped the waste processing needs for West Energy and its clients. Then we developed a sensor fusion technology, a system which combines sensors and machine learning to identify various waste fractions. And we, by prototyping the system, we pilot the system at West Energy facilities under real-world condition. And by getting the results, we analyze data and optimize the sorting and processing. One of the main perspective in this project was economical perspective. Of course, we can buy by 2 million euros different kind of systems like airports, like customs. This is not our aim. This economic perspective is very, very important for us. It will increase attractiveness for smaller operators, also the motivation to collaborate with us, and the amount of the devices we can create. So this is the first stage of our prototype. It's composed of very low cost microcontroller sensors, Arduino, Raspberry, Hilo, which are available everywhere. And we have used many sensors, as much as it was possible. Ultrasonic sensor, infrared, color detection, gas sensor, pressure, spectrum, LIDAR, capacitive sensor. Individually, each of these sensors maybe are not so practical, but when we are talking about sensor fusion, outcome is important for us. So mixing the output data and getting useful data from the fusion output is main target in this project. Beside the sensor fusion, we have used machine vision. And one challenge with the machine vision was the local data. Of course, we can always use open source data. We have millions of waste images and data open source, but we don't have finished waste. For accurate detection, we need local data. For example, if you think if you buy milk in America, it's totally different packaging comparing to Finland. So we need local data. That's why we manually or semi-manually annotated over 30,000 waste images. We got the data from market leaders company in Finland, Alte and Remeo, and we manually segmented it, and as you see, we segmented the data with bounding box with segmentation, and we are still working to develop this data, and maybe it will be the first open source finished waste data source. We have also summer workers who are continuing the annotation. But at the moment we have 30,000, which is enough to train the model. We have 7-8 classes: building and construction materials, glass and ceramics, hazards, special waste, large object, metal and electric, plastic and materials, and wood. And these classes are exactly the materials which bring the problems to the recycling process for waste energy. So for our prototypes, our aim was to have edge computing. We do everything as much as possible locally. And as I said in the beginning, for economical perspective, we used very cheap but very productive systems like Jetson, Hilo, Raspberry, and with these systems we can analyze even 30 to 60 frames per second to detect the wastes. And combining with this sensor fusion system with sensor fusion data with visual classification, we have combined data, and this is our novelty in the project, because as much I know, we don't have such a system. We have either classification or sensors, and this is the first stage of system. So we have sensor data, and also we have the visualization, and combining this together we get very accurate data for detection. One challenge with the sensors is the distance, maximum 20 centimeters. And when we have waste heap, then sensors are not typically working well. If we have belt, then sensors are very good. Also, machine vision works very well. But when we have heap, like 2-3 meters, 10 meters, then we need something else. Besides our system, we have also worked. This is very complicated at the moment, but we have worked on spectrum analyzers. So we have antennas, position antennas, which send radio frequency signal, and each material reflects specific frequency response. And with that data, we can train the model to detect is it metal or is it plastic. This is not so easy, because also the place which the all the, for example, if we think that waste are inside the truck, of course we have also metal uh, car material around that, but we are working on that. So for the future, we are working for spectrum analysis. We have planned to install our prototype in few recycling point in Finland, West Energy, and also few other places in Forsa and in North Finland. And when we have the real-time data, then we have endless possibilities. We can use for robotic sort systems, for data analyzing in real times, and this is the stage we are now, and lots of potential. This is a very potential project. We have some challenges, but I think soon we will have automatized or semi-automated system for sorting. Last year, Finland got a few million euro fine because Finland didn't reach the level of recycling. I think over 50 million or something, or less. A few millions. So if we could use these systems to increase the level of recycling, it's very good. Of course, it's also socioeconomic thing. It's depends to the area. Some areas in towns, of course, they have high recycling level comparing to others, but we are working on that. Thank you. If you have any question, I am ready to.
Yeah, so if you have any questions, we have this mic, and I can give this mic to you. Please, Anton, go ahead.
Thank you for the presentation. What's like considered a good result? Like if you have, for example, wood scraps, and then you sort it using your system, and then it comes out like 90% wood and 10% non-combustible materials. Is that good, or like how good does this system have to be?
At the moment, our machine vision is very accurate. But the problem is that if the reason we segment the data, it's because you don't. If you have belt, everything is separated. But if we have hip, everything is mixing together. So we are now working on that. If we detect, for example, wood, we can detect exactly with the round materials. This is one challenge because we have hip with mixing materials. We have glass, wood, but if we have visible shape, model is working well. And beside that, we have also sensors which help systems to detect.
Yeah, I myself was wondering just about the heap part. I believe there was, could still be, a Finnish company that was founded by a very well-known 90s musician that does this waste management. And they had demos on a belt, and everything was neatly separated, and a robotic arm. Yeah. Zen Robotics.
But in real world, we don't have belt. We have like 20 meters hips.
Yeah. How does the spectrum analysis work in that case, or did you have
we have tested, and we got some results, but we test in laboratory where there is nothing around.
Yeah.
So in real world, it's much complicated.
And also came to mind that could it be a possibility that a material would be visually fit for recycling or visually unfit, but then the spectral analysis would say otherwise. Or like for
Yeah.
example, if a glass jar had like some sort of woody material
Yeah, this is
on
one challenge
top
we
of
have.
it, or
Yeah,
Yeah.
false negative and false positive we have. But for waste energy, the system works like that. If we can detect, if we don't, nowadays the truck go directly to the point, and if we can install our system, if our system detects something, it doesn't go directly to the point. It's go to the checkpoint, so they can check manually. So this is how it could help them.
super interesting. Any other questions? Don't think so.
Yeah.
Guess we're done.
Thank you.
Thanks.